Practical SQL Server 2012 Administration and Programming, Sample Databases, Primary Key and Foreign Key, RDBMS Basics. RDBMS stands for Relational Database Management System. Let's look in Object Explorer to production.product table. And this is production.product. Let's pin Object Explorer window and expand. Looking keys. And we see primary key as product ID, and we see a number of foreign keys. Foreign keys are pointing to the primary key of different tables. So why do we need a primary key? And here are the columns. Product ID is indicated as primary key. Let's look inside the production.product table. So this is the primary key. It's just an integer. It looks like increasing, but that is inconsequential. It can be decreasing, it doesn't matter. It's a meaningless number. It's a meaningless integer, 4-byte integer, in fact, int. This is the primary key. Each table should have a primary key which uniquely identifies each row. Because if we can't identify a row, then it's hard to make any kind of processing function, because we don't know which row to process. For example, if an order comes in for product ID 771, we know that it is mountain 100 silver, 38 inches bike. BK is for bike. Now, name is also unique. Obviously, we don't want to name two different products the same name. That doesn't make any common sense. It doesn't make any business sense. We also have product number, so which is a little bit meaningful, because BK stands for bike, for example, and FR stands for frame. Why did we pick product ID and integer as the primary key, the unique row identifier in the production.product table? Why didn't we pick, for example, name? The reason is its simplicity and its convenience. This is a meaningless number. So if we have to refer to this row in a query or in a different table, we don't have to put in the entire English phrase from derailleur linkage. Enough to do the reference by product ID, which is a simple number 352. Similarly, product number is a bit closer to a product ID, but we can see the product ID is still simpler than the product number, which has some content. For example, we can tell from the encoding, we can tell something. MB is for metal bar, MP is for metal plate. On the other hand, 479 is totally meaningless. It is called a surrogate primary key, surrogate. It is a meaningless number. We don't have to change it ever. And that's very important. Assume we use name as the primary key, and we use it in foreign key to reference the primary as the primary key in this table, and assume we change it, we change the name. Well, it's not sufficient to change it in one place. We would have to change it in all our tables which are using it as foreign key. And this is the big advantage of surrogate primary key, which is integer usually. It can be big int as well. But there is no reason to change it. 415 can be assigned forever to this particular product. And in fact, we can go to up to 2 billion integers, and if that's not sufficient, we can use big int as a surrogate primary key. This is 4 bytes, big int is 8 bytes. But we know that the name has to be unique even though we don't use it as a primary key, and so is product number unique. So how do we see the uniqueness? Let's look in Object Explorer. In production.product, collapse the columns, and let's look at indexes. And we see a unique index on product number, we see a unique index on product name, and primary key is product ID, and that means it has a unique index. It is enforced, the constraint, the primary key constraint is enforced by a unique index automatically. In this case clustered, but it can be non-clustered unique index as well. Primary key must always be based on unique index. We also have row GID, which is unique, and this is used for system purposes such as replication. Let's look at a table where actually the product ID primary key is used as a foreign key, and that table is sales order details, select top 1000 rows, and we see a product ID. So this product ID 776 refers to the product table for this particular product. If we would have a name of a product here, it would take more room for particularly no good reason, except perhaps we could read it, but if we join the tables we can read it anyhow. And if we would have to change it, if we change the name, we would have to change it everywhere we use it. Meanwhile, the surrogate primary key does not require any change. And if we look at this table in Object Explorer, we see that one primary key and two foreign keys are defined. Let's count the product IDs in the production.product table, and it's 504. Let's count distinct product IDs, and since this is the primary key, it has to be distinct, so we have the same count. We are not going to have the same lock with list price. If we count the list price, 504, if we count the distinct list price, we see only 103. Obviously, this would not be good for a primary key, because there may be a bunch of bikes sold at the same price. Let's select product ID, product name, and list price. So these are the three columns we selected. When we see the list price as 0, that means it's an internally used product which is not sold to customers. It's used part of the assembly. And if we have a where clause to restrict the selection, so in sales order detail table we selected product ID 852, and we have 422 rows. So this is the one-to-many relationship. There is a cardinality of this relationship. This is in the production.product table. This is the one product ID, and there is 422 rows. This is the many part. In sales.sales order detail. This is how we select all the rows in production.product. And this is product subcategory. If we see we have a reference for product subcategory ID, it's a foreign key reference. And this is the primary key in product subcategory table. This is a categorization of a product naturally. And there is even a higher level category, and here is a foreign key product category table. The product category table actually quite small. Only 4. This is the 4 items. This is the highest level of category. This is the primary key. And the primary key becomes a foreign key in the product subcategory table. So this constitutes a hierarchical structure: bikes, components, clothing, and accessories. And this is the name. The name is unique as well. And if we join the production.product table, product subcategory table, and product category table, we have a meaningful query. The join happens on primary key and foreign key. So this is the foreign key in the product table joining the primary key in the product subcategory table, and the foreign key in the product subcategory table joining the primary key in the product category table. Let's see the result of this query. Execute, and we see now a nice categorization of the products. In fact, where it's quite meaningful. For example, this is components and road frames, and this is the actual product name. We can make the query even more meaningful if we add sorting. So that is order by category. Sorting is arbitrary. We can make it up any way we like it. Subcategory and list price descending. Let's run the query again. Execute, and we see that the results resorted according to our definition. This is the magic of RDBMS, Relational Database Management System, and the SQL language, that logically we stored the data in this instance in 3 different tables, and with an SQL query we join the tables and we bring the data together in a meaningful way. Let's proceed one step further. What if we want to see all the primary and foreign keys in the database? AdventureWorks 2012. Well, we can see it because data about the database itself is called metadata, and it is available in information schema views and system views. This is an information schema view. This is also information schema usage, and we are joining these 2 tables. In fact, we are joining them on constraint name and joining them on table name. So let's see the result of this query. Execute, and let's find production.product. We see that the product ID is a primary key, product model ID, product subcategory ID, size unit measure code, weight unit measure code are foreign keys in the product table. Let's check out where we find information schema views in Object Explorer. So we collapse tables and expand views, system views, and here are the information schema views. For example, if we select from information schema tables, we see all the tables listed in the database. All the views are included as well. We would need a where clause just to select base tables. Recapping, we have considered primary key and foreign key, and joining tables, the principles, the basics of RDBMS, Relational Database Management System. The interesting thing is that we can have hundreds of tables, yet following the primary key and foreign key design, we can connect them together and extract meaningful related data. When we consider a sample database, it was designed for training purposes. It was designed that we can easily understand. So if we look at the structure of, for example, a table, production.product table, it makes sense to us. However, in real life, we have to deal with entities and the corresponding tables that we are not that familiar with it. There is no common sense, there is no everyday business sense behind them, because we are very specialized. They can be, for example, financial instruments. They can be information processing for a very complicated business. And we can only model it and understand it if we understand to some degree the business itself, because otherwise the whole thing may not make sense to us. Of course, everybody can relate to a product because we are using products commonly in our lives, especially familiar with bikes. every table has to have a primary key, which is a row identifier, and also a table must have unique column names. So the intersection of a column and row gives a cell where we can store data. Data can be something like the list price. The primary key is used to uniquely store data in a table, but it is also used as reference to the data from other tables. And when such a reference is defined, we can use joins, such as inner join, to join the two tables together and extract data. This is the end of the unit.